Hello again, and this is a lecture on how to use Ohm's law and Ohm's law triangle. So first, let's put down the Ohm's law. So my Ohm's law was I, that's my symbol for current, equals V, that's my symbol for voltage, over R, which is my symbol for resistance. So first, I'm going to go ahead and solve a problem because the best way to illustrate this is to solve a problem. And I'm going to use the baby numbers for now. By the end of the lecture, I will not be using baby numbers, so listen closely. So first, I'm going to have voltage equals 5 volts. Notice, by the way, that volts are capitalized because that's actually a name of a person, someone called Alessandro Volta, who was an Italian physicist. Okay, and then I'm going to have resistance. And my resistance is going to be 1 ohm. And I'm going to write down ohm. And of course, I need to know what I'm looking for, and I'm looking for the current. And the symbol for the current, like I said, is always I. Don't ask me why. That's just the way it is. So the first things first, I need to write down my formula. I already have my formula right here. It's I equals V over R. So at this point, all I have to do is plug in some numbers. So I equals 5 divided by 1. That's an extremely difficult calculation. So in the end, I'm ending up with 5 amps. Now, guys, make sure you keep track of your units. Your current is always in amps. It's not in volts. So this is my answer. Well, this is very straightforward. We just apply the formula and things are nice and very, very peachy. Well, let's do problem number 2. Let's label these. This is my 1. Now I'm going to have problem number 2. Okay, so this time I'm going to have, once again, a voltage equals 5 volts, capitalized volts. I'm going to have a current, and my current is going to equal 10 amps. That's a lot of current, by the way. And I want to find resistance. Well, I have a bit of a problem. If I look at my formula over here, it tells me how to find current. It doesn't tell me how to find resistance. Now, you can do some algebraic manipulation and you can get resistance, or you can use Ohm's law triangle. Now, first I'm going to show you the algebraic manipulation, and then I'm going to show you the triangle. So here's how you would do it properly if you were in your math class. You would type out your formula, I equals V over R. And then you're going to probably multiply both sides by R. Then you're going to end up with I times R on one side, and then you're going to have V times R over R on the other side. Well, R's cancel out nicely, and you get V equals IR. But that's still not enough. We need to do one more. So once again, I'm gonna this time I'm gonna go ahead and divide by I. And I'm using this as a division sign. I hope this is more or less understandable what I'm trying to do here. here, a division sign. I divide by I. So this time I'm going to end up with an expression of this form. I times R, I times R divided by I per case, of course, equals V divided by I. And you can see that my I's are going to cancel this time. I can cancel this I can cancel this I. And now I finally have my final answer. R equals V over I. All right. So that took a while. Now, normally, if you had Algebra 1, you should be able to do all of that in your head. Well, if you can't, that's very unfortunate because you kind of need to learn how to do it anyway, but I will give you a crutch. And the crutch is called Ohm's law triangle. So first I'm going to draw a beautiful triangle. Hopefully I can do that. So let me actually first type it up. You know, I really like the triangle even though it is a crutch. I use it myself just because it's faster. But you do need to know how to do algebraic manipulation regardless. Here's one. Here's two. And here's three. So here's a very lovely triangle. And now I'm going to put in some stuff in there. So I'm going to put V on top. I'm going to put over I times R. And the way I usually tell people to remember it, and the way I remember this myself, the order that it goes in, is victory. Victory is on the top, so it's victory over insane robots. Okay, so victory over insane robots. So how are we going to use the triangle? That is very, very, very simple. So the way you can use your triangle, you cover up the quantity you're looking for, and the resulting expression is your formula. So this is how I'm going to do this. I'm going to grab this. This is my recording thing. I'm going to cover up R. What do I have left over? V divided by I. So I'm going to go ahead and type it in. R equals V divided by I. That's very simple. What if I had to find V? Well, I would just cover up V, and then I would have I times R. Very, very straightforward. All right. So now that I have my formula, I can actually solve this problem. And once again, this problem has baby numbers. So all I have to do right now is plug them in. So I'm going to have R equals to 5 divided by 10. And that actually equals to 0.5 ohm. I do have a bit of a problem here. This number that I have right here is not in SI notation and it's not in engineering notation. I have to convert it. You have to have all your answers in the proper SI notation. So when I convert it, I'm going to have 0.5. And then I'm going to move my decimal point by 3. 1, 2, 3. And leave it right here. So the answer I'm going to get is 500 times 10 to the negative 3. All right. Well, that's just engineering notation. If I'm going to put this in SI notation, 10 to the negative 3 is, of course, milli. And my units are, of course, ohms. So when I'm going to type it out, it's going to be 500. And let me move this over here. 500. And I'm going to write down milli ohms. All right, guys. So that's the second example. Uh-oh. Okay. Well, I do want to do one more example, but this time I'm not going to use baby numbers. Okay? This time I'm going to use real numbers, the ones that you will likely see in this class. So I'm going to have voltage equals 5 volt. 5 volt is a perfectly good voltage. And I'm going to have, well, actually, and I'm going to have, let's see, I'm going to have current equals 10 milliamps. Now, the very first problem, and I'm of course looking for resistance. Now, the very first problem I have is that 10 milliamps. I cannot have a number in milliamps and plug it into the formula. No, no, no. I will get a wrong answer. I have to convert it to amps. So I'm going to go ahead and do that. So this equals to 10 times 10 to the negative 3. This is amps. All right, now I can plug in. But before I do that, I need to know what I'm plugging it into. So I would go back to my Ohm's law triangle. And I already derived it last time that it's R equals V over I. But I'm just for kicks, I'm going to show you again how to do that. So I'm going to grab something to cover up my R. And the resulting expression is V over I. And that's what I'm going to use. Now I'm going to scroll down now. And I'm going to type my formula right here. Now, why am I rewriting the same formula over and over again? Guys, do that because chances are you're going to get confused which formula you're using. And you're going to have more than one formula, guys. So make sure you do that. So R equals V over I. So now I'm going to go ahead and plug this in. R equals 5 volts divided by, and I'm going to put all of this in the parentheses so it's clear that it's all in the denominator. 10 times 10 to the negative 3. Now, the very first thing that is sensible to do in a case like this is to put your 10 to the third in your numerator. Remember, when you have a negative power and you can change it to positive power if you go from denominator to numerator or vice versa. So I'm going to have an expression of 5 divided by 10 times 10 to the third. Don't forget to change the sign of your power when you switch it from denominator to numerator. So far, I have not done any math. I'm just rewriting the same answer over and over again. Well, 5/10 is also known as 0.5, isn't it? Times 10 to the third. And obviously, this number is not an engineering notation. What I'm going to do instead of converting right now is just plain multiplying it by 10 to the third. 10 to the third is 1,000. So half 1,000 is 500. So I'm going to end up with 500 ohms. And that is my final answer. Now, why is this my final answer? Because it's an engineering notation and it has proper units for resistance. Make sure you have your units. Make sure you have all of those things. And that's it.